All right, friends and neighbors, welcome back. We are continuing our discussion about Wireshark, what we like to do with it. And last time we introduced it, and this time I'm going to go over some of my favorite, sort of first step or next step tools beyond just grabbing a hold of those packets. So here are some ideas for today. We'll take a look at packets too, individual ones, and we'll take a look and see if there's anything that Wireshark might stick in there to make things, well, a little easier, but also sometimes, to be honest, a little confusing if you don't know what you are looking at. And so we'll take a look at that. And then we'll go right down some of the things in the statistics menu and see what we might use them for. And then lastly, we'll sort of take our next step in filters, right? We introduced some really basic filters last time, but we'll add a couple of ideas today. So let's get to capture. So I'm going to start a fresh capture here. I've been futzing around with this and prep for this, so we'll start a fresh capture. And remember that when you're starting a capture, you can pick your interface that you want to use. Since I was just capturing on my wireless interface, it's going to go ahead and pick that up. And we're generating traffic. Now I'm going to let this go for a little bit. And some of this is traffic from this particular node, but we have to remember that because this is wireless, it's picking up stuff around me as long as it's on the same channel. If I was wired, and even if I was plugged into a switch, I would still pick up anything that was broadcast, anything that was multicast, or anything that might have been flooded. So as this is going along here, let's go ahead and I'm going to do a basic filter. We'll start with TCP. Okay. And the reason I wanted to do TCP is because it's one of the easy examples where we can see that Wireshark puts extra stuff in a packet or a frame or a segment just to make your life a little bit easier, but we have to sort of understand that there's this extra stuff there. Okay, so we'll start with the IP header. Well, maybe we'll remind ourselves, right? So we have this frame stuff here, all the metadata, and we said last time this is not actually in the frame. So when I click on this, it clicks on the entire thing. And if I click on an individual field, you'll notice that there's nothing in the hexadecimal because this is not really there. It's all stuff that Wireshark is providing for us. Now, Wireshark does a very handy thing in the decode window. So in this example, we've got the identification. Now, the actual hexadecimal display down here matches this D8A9, but Wireshark does this base 10 conversion. Very handy if you want to deal with the numbers. But I want to show you another example here. Now, in this case, we've got this sequence number. Now, I've talked a lot about TCP in other videos. So if you want to understand sequence numbers and acknowledgement numbers, this is not where we're going to go over that. But I will say this. If I click on the sequence number, right, I can see that this starts at number 1, but I've also got this other sequence number here. But then if I look at the hexadecimal, I've got a different value. I've got A9076102. So here we have 3 different representations of the exact same thing. Notice that if I click on the raw number, the hexadecimal selection does not change. And so what we're seeing here is a couple of things. One is that the sequence number is a 4-byte field, and it is a byte count. We start with a random number, and that makes understanding what an individual TCP conversation is actually doing with the data. And so Wireshark does 2 things. It gives us the hexadecimal representation, but also the base 10 representation of that hexadecimal number. But then it also gives us a floor value. It starts the TCP conversation with very low sequence numbers, right? And acknowledgement numbers 0 and 1. And so when we're taking a look at this, if I was going to grab, say, let's see if we can find, we'll do a little bit of advanced here. We'll do a little flags. Right? And I'm going to look for a flag that's a SYN. So that's the beginning of a TCP conversation. When we apply this, you can see that, let's see, we can, we're still capturing. Let's stop our capture. I think we have enough packets now. Okay. And there's our SYN. So we're after a a SYN flag because this is the beginning of our conversation, and we can see we've got some very low numbers being used here. And this is to give us a hand. These are called relative numbers relative to this conversation. The sequence numbers start from these values, even though we've actually got these raw base 10 and base 16 numbers. Okay, so that is just telling you that, look, when you're looking in your packets, every once in a while you have to realize that some of it is actual, some of it is additional information that's been added as metadata, and some of it is an attempt to give you another way to look at a particular field. All right, so we'll get rid of this for a sec. And on my list here, I've got that we want to look at some statistics. Now this is the, we're just going to go down the statistics menu. We'll cover a couple of these. Now the first one that we'll take a look at is the capture file properties. Now why would I care about the capture file properties? Well, you can see some basic details about, how many packets are in there, things of that sort. But where I use packet capture file size is when I am writing code that captures traffic and then puts it in a file, but I don't want the file to become enormous. So you can get an idea looking at something like this of how much space a particular file with a certain number of packets is going to take up. And then when you write your code, you can say, I want to rotate to another file based on the number of packets, based on a file size. And that way you don't have these enormous files. You just have a collection of files that are all about the same size, and you're rotating through, and then you can parse through them or whatever you want to do. All right, so that is a handy thing to realize that you can do when you're coding or when you're storing things, when you're logging data, things of that sort. The next thing down our list here is the resolved addresses. Now, if we take a look here, Wireshark gives you a hand. Well, let me show you something else while we're looking at this. If I take a look at my Ethernet addresses for a second, my layer 2 or my MAC addresses, Wireshark is trying to give us a little more detail about it, right? Here's the hexadecimal, 6 bytes associated with this MAC address, but Wireshark is also trying to tell me a little bit about the resolved addresses. And so Wireshark, again, is trying to be very helpful in trying to tell you a little bit more about a particular address that's seen. Now, we have all kinds of addresses that are out there, right? We have unicast, broadcast, and multicast, in addition to the different vendor codes. So as we scroll down this, we can see that Wireshark is trying to tell me what it knows about all of the addresses that are seen or might be seen. So if we take a look at protocol hierarchy, this is very handy to understand the relationship between the different layers and also the families of protocols that you're dealing with. So if I collapse all of these, right, we can see that in this case, 100% of my packets were Ethernet. Now that we talked last time, that's not really true, right? Because I am doing 802.11. Now Wireshark is just showing them to me as Ethernet because I haven't done anything special to decode wireless frames here. If we open up Ethernet, we find out that we have these two other protocols that are buried inside the Ethernet header. And in this case, it's IPv4 and the address resolution protocol. Well, how does Wireshark know that? That's the ether type field, 0800 or 0806. And we can see that 95% of these packets are IPv4 and the remainder are ARP packets. Well, let's take a look at IPv4. And we can see that we can further drill down a little bit and see that 56% of those packets are UDP and the remainder are TCP and IGMP packets. So it's very, very handy sometimes when you're trying to understand the nature of your traffic on the network. Remember that when you're setting up flows or policies, security rules, access control lists, what have you, it's very important to know your sources and destinations and the kind of traffic that you're actually dealing with. And so this protocol hierarchy can certainly help us understand the nature of the traffic on your network segment. Let's do a couple of more. The conversations I think I mentioned last time, but conversations here can be at different layers. Now, I've said this several times, and I'll say it again now. It's nice to know your IP addresses, and it's nice to know your MAC addresses, but really, when we're worried about network design, or when we're worried about security or quality of service provisioning, what we really want to understand are the flows of traffic. And so the conversations that we're having, right? Source and destination IP address, for example, who is talking to who, and what percentage of my traffic. Now, I could take a look at this and I could see, oh my goodness, 1.3 and 1.255, the broadcast address, these two are talking a little bit here. I've got this conversation, but it's one packet. Do we care more about that, or do we care about this conversation down here? I mean, if I was going to look at issues on my network, I might be very concerned with the kinds of conversations that we're having. And then, of course, we can move up to layer 4 and see the conversations here. So conversations or flows is another very important way to look at network traffic. Take a look at endpoints. This is similar. We can get a lot of the ideas before, but this is all of the IP addresses or MAC addresses or ports that are seen, not necessarily who is talking to who, but we can see things like who are the big generators of traffic, right? Where do we see most of the packets or the bytes being created? So it's related to what we were just talking about. We'll do two more. So packet lengths. Now, there are lots and lots of conversations. We want to be aware of all the traffic that we have on a network, but there are lots and lots of conversations that are very, very short. They're very tough to measure the impact on the network, what we care about. In these cases where the conversations are short or they don't take up a lot of bandwidth, they're less concerning than our big senders. Folks that are having long conversations that use big packets and things like that. So it's very handy sometimes to look at what kind of conversations or what kind of flows are out there in the network. And we can see that of these flows here, I have a total of 722 packets that are generated here in this particular capture. So not very much going on. But if I take a look at my packets, I can see that, a majority of them are kind of small, right? The most of the packets that were generated here are actually small. And that's true in a large number of network conversations. Very, very short conversations and not a lot of traffic. And the packets themselves are kind of small. This one here is 40 to 79 bytes. But if I was doing FTP or HTTP or VoIP, would that profile be the same? We can see that there were a couple that were quite large, but not very many. But again, if I change the application, it might have a completely different look and feel to the flows that are out here. So when you're trying to understand those flows, the source and destinations, the number of packets, the size of those packets is really, really critical when you're trying to create a network design or when you're trying to address network traffic issues. So the last one that I'll point out here is that we have I/O graphs. Now, there's a lot of graphing inside Wireshark, and this is just one example. So you can grab conversations here or individual streams, well, I should say groups of streams, and you can see what is the I/O or the input-output graph here. So this is packets in 1 second, and so here's our time here over the course of this particular capture. And so if I change this, right, get rid of some things, we see some marked differences in the behavior of types of traffic. This is just another way. We're not going to do anything in depth here in this particular video, but it's important to realize that when you have the timestamps available to you, right, and the size of those packets, you can get and you combine those ideas, you can get a much bigger idea of what's happening in your traffic. Okay. We'll finish today with a look at some filters. Now, if I take a look at, so last time I think I did something like this, IP.source, and then we have the equals sign. So the equals is important. If I leave it as equals and I say, well, I want to look at 172.16.1. And I see 105 there as a source. You can see that it's still red. Wireshark doesn't like that. So I'm going to do the equals, and all of a sudden I'm green. So I go ahead and hit enter, or I hit the little arrow over here to apply it. and we can see that all my source addresses here are 105. But I could say something like this. I could say or IP.source, and we'll pick another one that's out there, equals 172.16.1.1. So now this means that I'm going to have either 105 or 1 in the source. Either one of them will match. We can see that in my source address column, I have either one of them. Okay, so that's very, very handy. Now another rule that we can apply here is the AND. Now this is going to be a ridiculous statement. The syntax will be right, but it won't work. So this will say I want a particular IP address and another one as the source, and that doesn't make any sense, and that's why it doesn't work. But the important thing is that you can use or and. And what I'll do here is I'll say that particular address and maybe TCP, since we know there's TCP traffic. And there we go. So now if I was to take a look at these, all of this traffic should not only be TCP, by the way, HTTP is TCP, and I'll have the source address here. Now let's tie two ideas together. So that's equals equals. We've got or, we've got and. Now what happens if I go up here and take a look at my statistics? And let's do protocol hierarchy, for example. Now that I can see, if I take a look at this, I can see that all of this traffic now is of a particular type. Now I can do different filters. In this case, I'm drilling down and I'm seeing that I've got transmission control protocol here at 74 packets, but of those 74 packets, 14 of them are HTTP and the rest are just standard TCP. The tools that we use in the statistics menu can be combined with whatever filters you're using to take a look at a set of packets. And that's a very powerful thing to remember, because now we're looking at the hierarchy of traffic that involves this particular address and this particular protocol. I might also do the same thing with, let's see if there's any IGMP out there. And you can even do this. We'll do this one more time here. And IGMP or ICMP. Right? We'll close that like that. So now what I've done is I've done that order of operations thing that we've all come to know and love with arithmetic. And these things can be combined in Wireshark filters as well. And so now I've got 105 as my source, and anything that's IGMP or ICMP. There's no ICMP in this particular capture, but you can see that it all popped up as IGMP. Well, there you go. There's our sort of next step stuff. So our friend the basking shark will help us close out today. Remember, this was a closer examination of packet content, right? What Wireshark might add for us, and a view of those statistics, right? I'm just going down through the menus and making use of what I can see there. We also took a next step look at some filters, right? Remember that we have the equals equals, but now we've seen that we can do that order of operations thing with and, or, and we did parentheses as well. Well, the basking shark says like and subscribe if you are even more jazzed about packets. And no matter what kind of filters you're using or what kind of stats you're looking for or what kind of shark is chasing you down, may those packets always reach their destinations.